In section 3, we want to learn about function notation. Here's a function. What do we get when x is a 3? Well, that means put a 3 in place of the x and do the calculations. What do we get when x is negative 4? That means put a negative 4 in place of the x. Do the calculations. What do we get when x is 0? Put a 0 in place of x. Use the calculations that you know to do. Now, this is where we need to introduce some notation so all of this can be asked in a more compact, convenient way, at least for math people. We're going to start by giving our function a name. Now, traditionally, we use one-letter names. For functions that don't have a particular meaning, we oftentimes just use the letter F. So we'll use that for this function. As you'll see later, sometimes we give functions names that sort of relate to what they are, like velocity, V, revenue, R, and things like that. But this one we'll just use an F. We specify by putting in parentheses next to the name what the variable is going to be. Now again, if you look at the notation, F parentheses x does not mean F multiplied by x. It means we're talking about a function named f and the variable is x. And so we see this notation a lot. F of x equals 2x plus 3. The important thing to notice is we're not solving anything. This is just a sentence that says you've got a function whose name is f, the variable is x, and it happens to be a 2x plus 3. Now, when we see f parentheses 3, that symbolism tells us plug a 3 into the function. This we've already done, and here's the symbolism for it. Plug these numbers into the function. Look at this. It means instead of the x, put z. Now, there's no simplifying or putting together that we can do on this. That just comes out to be 2z plus 3. Same thing with the a. But here, if we plug in a plus 3 into the function, we do have some simplifying that needs to be performed. The 2 times a and the 2 times 3 can be multiplied out, and then the 6 and 3 can be put together to give the 9. Here's two functions named f and g, typical names for functions. And f parentheses 3 means we plug a 3 into the x of the f function. G parentheses 7 means we plug a 7 into the x of the g function. Now have a look at this. This means start with the f function and plug a 3 in. Now we've already done that. That comes out to be a 7. And so then we want to evaluate the g function with a 7. This is called function composition. Do you see what to do for this one? We start by plugging a 2 into the g function. Then we take that answer and plug it into the f function. So again, it's all about the notation and the symbolism. Have a look at the picture. This is a function. We don't have a formula for it, but still we need to be able to answer questions concerning it. First off, notice the domain of this function is the numbers along the horizontal axis, kind of like the x's. And the range is the numbers along the vertical axis, kind of like the y's. And so again, this is in the format of a function. F parentheses 1980 means what do you get when x, or the year, is 1980? Well, you can see here's 1980, and the dot for 1980 comes out to be somewhere between $1 and $1.50. So we would estimate that to be about $1.20. Finally, we're given a problem like this. Lots of information going on here, but basically, do you see here in the middle, we have a function. V is the name of the function, T is the variable, and the stuff over here tells us this is what it is. Now, if we're given a question that says find the value, well, if you look at the explanation up here, the value is V. So we're looking for V when the painting is 15 years old. So if T, number of years since the painting was purchased, is 15, we need to plug a 15 in place of the T. So we're doing V parentheses 15. And so let's plug a 15 in place of the T and see what to do. You learned this before in the Chapter 1 review. We start with the 15 divided by 5. That's a 3. Then we do the exponent. That's 2 to the 3. That's an 8. Then we do the 125 times 8. And so there's how we would answer that.